Good morning, students. Happy Tuesday. Sorry if I talk kind of rushed. Didn't realize I have a 9 a.m. math meeting, a 10 a.m. leadership meeting, and then the 11 a.m. Zoom. So we're just going to jump right in today. Hope you guys are having a good week so far, and I hope this stuff's teaching you something new. The new TikTok is going to launch today at 11 a.m. Go ahead and check it out, Coach Siegel 615. This character has something to do with it. It's a little self-deprecating humor. I think you'll think it's funny. Alright, some quick reminders. One-on-one calls have been going great. So if you want to catch up, again, there's no interview or anything like that. It's just me just catching up with you, making sure you're doing okay. If you want to do that, sign up on the Sign Up Genius. It's on the Everest that I sent on Sunday. I talked to 5 people yesterday. I have another 3 today and 2 tomorrow, so it's been going really, really well. Second and third period, your Zoom call is today at 11. Second and third period today, which is Tuesday. Fourth period, Wednesday at 11. Thursday, sixth period is on 11 o'clock. Here's your bell ringer. Go ahead and click pause in 5, 4, 3, 2, and 1. Welcome back. Here we go. So choose which of the following numbers are solutions to the below inequalities. So you have to plug and chug and say, is it a solution, yes or no? So is 0 plus 4 greater than 26? No. So 0 is not a solution. Is 5 plus 4 greater than 26? No, because that would be 9. Is 10 plus 4 greater than 26? No, because that would be 14. And is 30 plus 4 greater than 26? Yes, so 30 is a solution. 2 times an unknown number. Remember, 2 next to a coefficient, or a coefficient next to a variable, means to multiply. So 2 times 0 is not greater than 10. 2 times 5 is not greater than 10. But 10 and 30 are solutions, because 2 times 10 is 20, and 2 times 30 is 60, which is both greater than 10. 10 minus x, plug and chug. Is 10 minus 0 less than 0? No. Is 10 minus 5 less than 0? No. Is 10 minus 10 less than 0? No. But 10 minus 30 is, because that would be negative 20. So 30 is a solution. I hope you guys are understanding this. We're just trying to see which of this solution set from the top makes the equation or inequality true. So is 30 times, or is 3 times 0 90? No. Is 5 times 3, 90? No. 10 times 3, 90? No. But 30 times 3 is 90. So 30 is a solution. And then we also know 30 is going to be a solution here, because 30 plus 5 is equal to 35. Cool. Your school has a show, and they need to sell 65% of 200 tickets. How many tickets do they need to sell? You would do this like this. 65 over 100 is equal to x over 200. Or you can just turn this into a decimal. Percent means per 100. Move the decimal 2 places to the left, and you get 65 hundredths multiplied by 200, and that gives you what? 130. What does that 130 mean in the context of the question? You must sell 130 out of the 200 tickets in order to be successful. You're going to the Beyonce concert. It is a flat fee of $10 plus $95.25. Write an expression to determine how much the cost is. So there is a flat fee of $10. So Ticketmaster is going to charge you $10 no matter what, plus how many tickets you buy. Multiply that by $95.25. So it'd be $95.25 x. That is the expression. Remember, expressions do not have an equal sign. Okay, and what does the x represent? The x represents how many tickets you purchase. Cool. The unit price. Remember, unit price means the price for per one. Money always goes on top. So you do $22.75 over 7 cars. Go to 1 car, so you divide by 7, $22.75 divided by 7 is $3.25 per car. So $3.25 per 1 car. Same thing here. $11.97 for 9 bananas. You want to find the cost of 1 banana, so we divide by 9. $11.97 divided by 9. Gives you $1.33 per 1 banana. 5 loads of laundry for $10.95. What goes on top? Money. Money, money, money. Sorry, I was obnoxious. Divide by 5, divide by 5. You get $10.95 divided by 5, and you get $2.19. And then these right here should be easy. Name the 3D shapes of the net. This is a triangular pyramid. Ooh, or is it a prism? I think it's a prism, actually. Triangular prism. This is a cube, and this is a rectangular prism. Cool. We're going to jump right in. So this is a box plot. Remember, a box plot summarizes a big set of data using 5 major points. We always want to look at it and find our 5-number summary. So our 5-number summary here is our minimum. We're just going to call that 5. So we're going to say the minimum is 5. This is your 5-number summary again. Your maximum, we're going to call that 42. And then your lower quartile, or your first quartile, remember where the box starts, we're going to call that 17. 17, 38. And your median is 20. And then our third quartile, let's call that 22. So that's your 5-number summary. Meaning, so 25% of the data from here to here, 25% of the responses go from there to there. Another 25% of the data goes from quartile 1 to the median. Another 25% goes from the median to quartile 3. And another 25% goes from here to the maximum. So that shows you a summary of where 100% of the data points lie. Here's a meme for you, Jamie. Hope you enjoyed it. It's finger looking good. Haha, it takes the Zaxby's comment. Get it? Yeah. Great. Here's another box plot. Let's talk about the number of dogs. Also, stay with me. At the very end, I'm going to teach you how do you create a box and whisker plot based off data. So the number of dogs. This survey was asking how many number of dogs do people have in their household. So the minimum is 0. The max, be very careful. You don't look right here. You look to see where the number is. So the max amount of dogs is 8. The first quartile, or quarter 1, so quartile 1, is at 1. The median is at 2. And quartile 3 is at 4. So, we know that 25% of the students that were surveyed have 0 to 1 dogs. Then 25% of the students have from 1 to 2 dogs. 25% of the students have from 2 to 4 dogs. And 25% of the students have from 4 to 8 dogs. So again, remember, these are summaries of your data. How do you analyze a box and whisker plot? Here's another meme for you meme people who said that they were tired of not seeing memes. I have no idea what I'm doing. Get it? It was about dogs on computers, technology, funny, haha, great. So this is a little bit different. So I want us just to look upon this. We're not going to do any 5-number summaries for all these. That's too much work. But I want us to see how you can compare different box and whisker plots. I want you to tell me what's wrong with class 2. Okay, so with my Dora Explorer moment, you should notice that there's no whiskers on the box and whisker plot, so it doesn't show you a minimum or maximum. What it did is it put the quartile 1 at the minimum and quartile 3 at the maximum, and that is not a true spread or distribution across the box plot. So this is incorrect. And then we don't know about class 1 or class 3. However, we do know that you these are two different data sets, and they both compare different sets of data correctly. There's a minimum, a maximum. The medians are the exact same for all three data sets, and it looks like the maximum and the minimum are both the same for class 1 and class 3 as well. Here's another one. When the teacher walks up to you during an exam and looks at your paper and shouts out, "Guys, please make sure that you read the questions carefully." Give me a comment or a like if I've ever done that to you during a class, quiz, test, or anything. Tell you guys to take a deep breath and actually read carefully. That is the face that you guys give me, 1000%. The box plot below summarizes the maximum speeds of certain kinds of fish. These fish are fast. I've never seen a fish that can swim 70 miles per hour, but, you know, good example. So let's do the 5-number summary one more time. This time click pause and I want you to do it first. What is the minimum, the maximum, quartile 1, 2, 3, and so on? Welcome back to Connor the Explorer. So the minimum is 35. The max is, let's say 68. It's okay if you put 67, we can't tell. Quartile 1, let's say is 38. The median, let's say is 42. Quartile 3, it should be Q3, I don't know why I keep writing 3Q, would be 48. So that's our 5-number summary. Then if you want to break it down into quartiles, you know that 25% is here, 25% is there, 25% of the data is there, and 25% of the data is there. Sweet. This is you guys putting your iPads into the wrong place over and over and over again. Ha ha ha. Okay, sorry about the pause. First thing, I had to log into my professional development training. So let's look at the best actor compared to the best actress. So, the best actor, their age ranges from the 30 to the 75 range. So the range is like from 30 to 75-ish. And the actress is from 21 to 80 or so. And then we can look at the interquartile range, which is the quartile 1 to quartile 3, quartile 1 to quartile 3. We'll go to the minimum, the maximum, and compare basically different data sets. So what do you notice about this data set? Immediately you could say, well, the men are younger just because there's a outlier out here. The minimum is lower out here. However, we need to look at the overall box plot. Look here and see that basically 75% of the data of females is below the age of 40, wherever most of or basically 75% of the males is over the age of 40. So that's a way to interpret this plot. There's a creepy Shrek meme again for you, Jamie.
Let's cough. That's
if you guys hear some talking in the background, it is because I'm watching this PD with the entire district while still trying to do this at the same time. So I'm just trying to make sure I'm not missing anything. They're not talking to me. It's like 300 people in this conference. Okay, so here's what we're going to do. We're going to learn how to take a box and whisker plot right here. Thankfully, the data is already in order for us from least to greatest. So your first step is to put it in order from least to greatest. Then you want to find the minimum and the max. Then you're going to find the median, and then quartile 1 and quartile 3, and I'll show you how to do that here in a minute. So let's write our 5-number summary off to the side. You have your minimum, which is 13, your maximum, which is 20, quartile 1 we don't know. Quartile 3, we don't know. And our median, we're about to calculate. So we do the same thing that we did before with our other data sets. So we go from each end, we cross out one at a time until we get to the middle. And this is easy because all of what's left is the 17s. So our median is going to be 17. And then we have to find our upper quartile. And the way we find our upper quartile, or quartile 3, is we find the median up from the middle up to the upper half. So this is going to be a really, really rough example, but we will get more into it on Wednesday and Thursday this week. This just has to go quick. Okay, so now we're going to find the median of the upper half of the data. So we cross out the 20, cross out the 17, and the 19, 17, and the 18. So their upper quartile is going to be 18. And just by looking at it, I know that the median of the lower half of the data is going to be 16. So now if we want to make our box and whisker plot, I'm going to give us a little number line here. What if I can get a shape? Nope. Okay, so we're going to do a number line, and we're going to have our start at 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. We're going to plot points on our minimum, our maximum, our median, which is 17, quartile 1, and quartile 3. We draw a box around the two quartiles, put a line through our median, and extend to our minimum and our maximum. And that's how you create a box and whisker plot according to your 5-number summary. We're going to go deeper into this a little bit on the Zoom today, I think. And there will be lots more examples of how to make a box and whisker plot here. If you want to try to make a box and whisker plot, it is on my website. Thanks for your patience. I know this last part was kind of annoying. See you guys later. Check out the drop here in a minute for TikTok.